Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. I am Farah Cindyanita Saputri from Electrical Engineering Department of Politeknik Elektronika Negeri Surabaya. First of all, I would like to say thank you to the Committee of International Conference on Industrial Mechanical, Electrical and Chemical Engineering 2020. I'm here to present my paper entitled Design and Simulation of Single Input Multi-Output or SIMO Flyback Converter using PI Controller for Emergency Power Supply. And here is the outline that will be discussed on this presentation. The first one is the introduction, and second one is the system design, and followed by simulation result. And last but not least, the conclusion of the simulation result that has been discussed on the paper. And here are the introduction. Natural disasters that occur in various regions often have an impact on electricity. One of the impacts is power outages. The importance of electricity supply for electronic equipment during emergency conditions, such as PC or notebook and cell phone, forces the electricity needs to be fulfilled and supplied continuously. From that issues, emergency power supply is the solution to overcome the problems. However, the most common of emergency power supply or EPS is only intended for single input, single output needs. Whereas, to overcome the problem of emergency electricity needs, it is needed a system that can provide for more than one output with different voltage level. So, this paper proposes a single input multi-output emergency power supply that can provide a multi-output system that has two different output voltage levels, which is specified for charging notebook and cell phone. And this is the system design. And the picture shows a block diagram system, which is the overall system using batteries as the main sources, and flyback converter with the two output to provide for charging the notebook and the cell phone needs. And here are the parameters of flyback converter and the transformer of flyback converter. Where is the parameter for the input voltage come from two batteries with value 24 volt DC, and the frequency switching is 50 kHz, and the duty ratio is percent or a half, and the value for the first output voltage for charging the notebook is 19 volt, and the value of second output voltage for charging the cell phone is 10 volt. And the next table shows the transformer of flyback converter parameters. There is a magnetizing inductance and the nominal for primary turns and the secondary turns. And here are the block diagram of PI controller for overall system. The PI controller can be placed on the first output from the converter and on the second output. We can place it as our desire. The PI controller that is used in the system is obtained from the simulation response of the flyback converter, which uses the predetermined parameters. And here are the open loop transfer function or ULTF and the closed loop transfer function or CLTF. This simulation assumes constant input voltage and constant load under steady-state conditions, which using two batteries with the capacity of 12 volt as the input voltage. The response from the simulation will be compared in open loop and closed loop, which is shown by the table. The simulation results of the system with the first output voltage as the feedback In this case, the first output voltage came from the output for charging the notebook. This simulation result shows that the PI controller stabilizes the voltage at 19 volt in a shorter time period than with no controller. The input voltage is varied from 20 until 25 volt. The PI controller always brought the output voltage of the flyback converter back to the set point 19 volt in a very short time period at 0.017 second or 17 millisecond. However, the flyback converter has only one switch to control the output voltage. The PI controller can only obtain one desired set point in one selected output side, while the other output side follows the regulation that is set by the PI controller. This statement is mentioned and shown in the next table that use the second output voltage or 10 volt as the feedback of the controller. So, if the table A using the first output as the feedback and the table B use the second output voltage as the feedback. In this case is output voltage from the parameter for charging the cell phone, 10 volt. From this simulation result of the system with the second output voltage as the feedback using the same input nominal conducts that the output voltage at 20 volt and 10 volt with a response time in 0.035 second or 35 millisecond. It has proven that the flyback converter, which has only one switch, can only obtain one desired set point in one selected output side as the regulation of the PI controller. And comparison of the two simulation results in different feedback parameters conducts that the closed-loop model that uses the PI controller has a better response to obtain the steady-state output voltage as proposed than the open-loop model. It shows that the system of single-input multi-output flyback converter using PI controller for emergency power supply can obtain the desired output voltage in stable condition as the design for charging the notebook and the cell phone needs. Here are the simulation response in open loop and closed loop. This is the graphic 20 volt input voltage in open loop and closed loop. We can see from this figure that the voltage brought into set point. And this is the simulation response with 22 volt input voltage. And the next from 24 input voltage. And the last with 25 volt input voltage. From 4 figures previously shows that the closed-loop model or PI controller in the system always brought the output voltage back to the set point. According to the simulation result that we just discussed, the closed-loop model that uses the PI controller has a better response to obtain the steady-state output voltage as an emergency power supply for the notebook and the cell phone charging needs. And to obtain output voltage of the closed-loop system with the feedback control from the first output voltage is 90 volt for the first output and 9.5 volt for the second output in 0.017 second or 17 millisecond. And to obtain output voltage of the closed-loop system with the feedback control from the second output voltage is 20 volt for the first output and 10 volt for the second output in 0.035 second or 35 millisecond. And the last one, the efforts for getting the output voltage as desired are hindered by the fact of a flyback converter has only one switch to control the output voltage only in one selected output side of the converter. So that's all from me. Thank you very much for all the kindness and your attention. Wassalamualaikum warahmatullahi wabarakatuh. Have a good day, everyone.